Today we're going to talk about O2 sensors on a 2019 Jeep Renegade and on a 2011 Chevy Equinox. Here's 1 O2 sensor, which has 5 wires, and 1 has 4 wires. The O2 sensor on the Jeep Renegade is a wideband. During normal operations, the O2 sensor reference voltage and O2 sensor signal voltage will be fixed voltage value. The O2 sensor current pump voltage will switch from between 0.45 volts above and below, depending if it's lean or rich. If the exhaust stream is lean, the voltage will be above 0.45. If the exhaust stream has a rich, it will be below 0.45 volts. The 4-wire generates its own voltage signal between 0.0 volts and 1.0 volts. It has a bias voltage that the PCM shifts the signal voltage to fluctuate between 2.5 volts and 3.5 volts, depending upon oxygen content. If it's lean, the sensor produces a low voltage. If it's rich, the sensor produces a high voltage. Here's a wiring diagram for the O2 sensors. For the 5-wire, there are 6 wires in the wiring diagram. However, there's only 5. It has a pump cell current signal, a heater control and return signal, and also ground. For the 4-wire, it has a half signal, return, heater control, and ground. We plugged in a scan tool and we made PID values. Here's a chart of the sensor 2's volts, which is 3.30 and fluctuating, and sensor 1 is 2.1 and fluctuating. But as you can see, with higher RPMs, sensor 1 goes remotely up as engine RPM goes up, and sensor 2 goes slightly up, not very much. Here's a 2011 Chevy Equinox. Run mode has 2 conditions called open loop and closed loop. The engine first starts and the engine speed is above predetermined RPM. The system begins open loop operation. The ECM ignores the heated oxygen sensor and calculates air-fuel ratio based upon ECT, MAP, MAF, and throttle position. For fuel trim, make sure to look for positive or negative fuel trim values. The ECM indicates a positive value if it's adding fuel to compensate for lean condition, and a negative value will indicate compensation for a rich condition, which is reducing the pulse width. Here's a caution about the silicon contamination of heated oxygen sensor. Please pause to read it. Here's a wiring diagram for the heated oxygen sensor. Both of the sensors have supply voltage, ground signal, and heated signal.
Our upstream O2 is located on the back of the engine as well. Just right back down in there. You can see it. And here's our plug for it. And it is also a 4-wire sensor. We are down underneath the car on the downstream O2. It's on the back side of the engine, and it is a 4-wire sensor, which means that it is heated, and we will have to look at all data to determine what type of sensor it is. Here we are testing the resistance of the upstream O2, and this is with a little bit of heat in it, but it is reading around 7.1, 7.2 ohms.
Here's the reading for the downstream. It says 6.8 ohms.
Okay, here's our PID list at idle. We have our pedal position, air-fuel ratio commanded, engine speed, our heated oxygen sensor voltage for upstream, our heater command for upstream, our oxygen sensor voltage for downstream, and our heater command for downstream, our duty cycle for our injectors, our long and short-term fuel trims, and our MAF sensor, as well as our throttle position. This is with the engine running. I'm going to give it some RPM now. And you can see how those voltages move around. Give it some revs. As you can see, as I open that throttle up, our O2 sensor voltage drops upstream as well as downstream. And our commanded AFR is around 1 at all times. I'm not sure how to get that to change. We are now causing a misfire on cylinder 2, and we're going to see how that affects things. Plug unhooked, not an injector, so we should be reading richer than previously, and it appears that we are. We're reading a little bit richer, and our math is going up. We're going to see what happens with a little bit of RPM here. And as you can see, that sensor is reading a very low voltage, which would mean that it is very lean. Okay, now we are going to create an intake manifold leak by just popping that off there. Okay, and now we're going to graph our AUT sensor readings, MAF sensor reading, and our short-term fuel trims. This is with a unmetered air leak. As you can see, we're sitting fairly rich right now. And our MAP sensor is reading lower than usual. Short-term fuel trims are high. We're gonna give it some RPM and see how that affects our sensors. Okay, next we are going to be feeding propane into the intake on a Chevy Express van with the 6-liter. As you can see, the wiring diagram for this is very similar to the Equinox, except it has 2 banks of O2 sensors instead of just the one. Ready? So yeah. As you can see, as we feed propane into the engine, the O2 sensors are reading very, very rich. They're up at 900 millivolts, which would be 0.9 volts, and the PCM compensates for this by pulling the fuel trims down to around -9, 10 on there. So